All right, well, thanks everyone for joining us today. Lance, are you ready to get started?
Yes, I am.
Okay, terrific. Yeah, you can go ahead and advance to the next slide for me.
Yeah.
All right, so hey everybody. I'm Annalisa Russo from the Partnerships and Community team at Formlabs. And today we are joined by Professor Lance Winkel. He's a designer, a 3D artist, a filmmaker, and he also has teaching positions both at USC and the Otis College of Art and Design. In addition to that, Lance is a good friend of our team. He's one of our first Formlabs brand ambassadors and has extensive insights to share about SLA 3D printing. And more specifically today, he'll be covering an introduction to Maya software and how to leverage that program for modeling multi-component structures, as well as visualizing and preparing a 3D model for printing. So before we get started, we just have a little bit of Formlabs housekeeping on the next slide. This webinar is part of our Formlabs Comes to You series, where we've been inviting experts in 3D printing to share their work and answer your live questions over Zoom. So we encourage you to check out the website that's on this slide to find archived content and to also see what's coming up next. And next slide. So finally, during the presentation today, please feel free to use the Q&A button within Zoom to ask your questions, and we'll get to those at the end of the hour. So with that, Lance, I'd love to hand the screen over to you to learn about Maya.
Awesome. Okay, so let's get this out of here. Boom. Okay, so I need to get you lined up there. So good morning, and looking forward to showing you a little bit of some of the tools and techniques that I've developed and kind of get you a really good foothold into understanding how you can use Maya for 3D printing. A lot of times we're used to seeing 3D printing, other programs get used and talked about quite a bit. ZBrush. We hear a lot about CAD programs, and so I have gone to trade shows and been diving into the things I do in Maya, and people show me some shock and say, wait, you're using Maya for 3D printing? Famously, one of Autodesk's own staff members at the Formlabs User Summit last year in 2019 was shocked, like, wait, you're using Maya for 3D printing? I'm like, you are the company, like, you should know this. So you can do a lot of really amazing things with Maya and 3D printing. But I want to say up front, if you come from a CAD background or you come from ZBrush or a different program, while as much as I'm talking about Maya, I'm also going to be talking agnostically, and I will be the biggest advocate that says to you, use the programs that are going to help you to get results. There are a lot of really powerful features that are part of Maya's tool set that work great for certain things, but there are times where I find myself in a CAD program like Fusion 360, and I find myself jumping between different programs where I may have content that starts in ZBrush or starts in Fusion 360, or even bounces back and forth between Maya, then into CAD, then back into Maya. A good example of that is what you see in the Maya screen right here. For some of you who may have been at a few of the Formlabs user summits or may have been at SIGGRAPH in 2019 or 2018, you may have seen this sitting at the Formlabs booth. This is a part of a sculpture that I did a few years ago called the Tomb Guardian, and it really showcases some of the most powerful parts of what you can do in Maya that may not have a direct transit. There might be programs like Houdini and other programs like that have that some of these capabilities. But what this is a product that started as an initial visualization. I knew it was going to be 3D sculpted. I knew that there was going to be LED wiring involved. I knew that there was going to be a limited setup time. And at the same time, it was going to be a sculpture. So I wanted to make sure that I knew it was going to work before I spent the 72 hours worth of 3D print time to make it actually finish. I apologize for the sound of a really, really powerful sports car engine outside of my window. Hopefully they will be gone soon. So what you're seeing here is a model that started off as a series of sketches, was evolved into a series of NURBS geometry as well as CAD geometry. Then I did all of the manufacturing elements in CAD, and then I was able to bring those geometries back over into Maya and do a full character rig. The same type of rigging tools that you'd see in a motion picture film or in an animated film. So I have a series of joint hierarchies. I have a series of deformations that are allowing me to deform this like it's a character, but now I can take that character data and prepare it to go to 3D print. Now, the other thing that I wanted to show, and it's why this is the first frame we're looking at here, this is a Maya camera that we're looking through. And you can see at the bottom it says BMPCC 6K, the same picture that my head is getting looked at with the same resolution of sensor is what I'm literally looking at right here. One of the big powerful things that came out when Maya was developed is, and it's what made it so advantageous for the visual effects industry, is that you can make physical cameras that are accurate to real world cameras. You could make a Panavision Millennium camera right there. In this case, I could simulate a Blackmagic PCC 6K camera with the exact 35mm lens that I'm currently looking at, or you guys are currently looking at me through, and I can look at my object through that lens. Okay. We have the ability to make custom cameras, so I can actually look at my models in Maya, what we call pre-visualization, which is what I historically have done in the film world. Pre-visualization allows us to look and make commercials in the computer before we ever go on set. It's what allows them to make a motion picture and know that all the visual effects elements are going to fit within the shot before you ever actually take that camera to set, before you ever actually bring all of those hundreds of people together to shoot that set. Well, I'm pre-visualizing a 3D model that before I ever take it to the 3D printer and before I've ever actually finished and gone to STL, which is the 3D print format that we're going to be talking about. And the reason I wanted to be able to do this, as you can see in here, this is looking through a camera, just like you're seeing me, but I can literally set up my camera to look at it and make sure that my overlaps of my shots, if I start looking at how my structure is, I wanted to make sure when I was setting this up that I was going to have this kind of perfect sweet spot. And that sweet spot that you see here is, this is like a little stage. This was being done for a miniature diorama. There were going to be some very heroic looking figures that were put on this stage and kind of the last stand against the Leviathan. And I wanted these very, very large tentacles to not overlap. I wanted them to look like they're wrapping around, have all of that movement as they're moving around. And I wanted to stage it and know that it was going to work before I go and just print something and then try to figure out how to bend it there. So Maya allowed me to do that. Now, how does Maya allow me to do that? Well, we're going to go a little closer in here and we'll kind of see. One, just like any 3D program, it is a virtual world. And if we use metric as our base of measurement, Maya's default is to work in centimeters. So you are working with a default world that is measurable compared to your real world. And so by setting up my stage, setting up my exact stage for the size that the entire presentation would be, this was the size of my table, by being able to know where everything had to be. There's some of the section is missing here. Those pieces are actually there. They're just hidden away from you right now. You can see some of them down below, but I knew where my exact size measured with my calipers of my stage was going to be. I knew where my main figures were going to be. I knew the direction of my camera where it was going to be. And what I wanted to be able to do was start lining these up so that I got, like you can see there, all of that motion, all of that sense of cinematic quality to a printed 3D model. Okay. Now, what this is character rigging. You build a joint hierarchy. Now, in this case, it's using what we call a spline IK, which is used for character spines, tentacles, ropes, things like that. there's a lot of resources out on the internet that can get you understanding of how to do this type of stuff. But by me taking what starts off as, these are actual STLs exported out of, these by the way came out of Fusion 360. I had already built in all of my wiring. I had already planned in my channels for where the LED wires were going to be. I had actually even, if we look at this, I had even built in all of my plugs and glue mounts and points where it was going to solder together. Okay. But then I bring it back into Maya. Then I can go through and actually set it into the rig. And I can do certain really powerful things in here. Now, many of you are going to go, but wait, how do I learn that in 5 minutes? The answer is, you're not going to learn it in 5 minutes. And my goal today is not to go through a rigging lecture or to go through all of the little fine minutia, because you can find that in YouTube. You can find that on Autodesk's own documentation. There are whole areas. There's even auto rigs that have already been built. So there's a lot of resources out there that if you just get excited and you start diving in, you'll be able to get a lot of that information for yourself. Okay, but I want to show you a little bit of things that can be applied to your work that can help you with your workflow. And one of them is what's happening in here. So I've got this sets of controllers, but on the end of my controller, I also was coming across certain areas where, as I start to move things around, see how we can suddenly, we get areas where there's overlap. Now, when I export to a 3D printer, I put this on the preform stage, it's a good valid model. It's going to print perfectly. But when I try to glue them together and mount them together on the model, this piece and this piece, as you can see here, they're overlapped. So what's going to happen? They're not going to fit. Now this piece, because it's all part of the same mesh, that will just end up becoming kind of a solid sculptural overlap. Okay. I might get an error warning or two from the 3D printer application, but it would still print and print effectively. But areas like this, I would have a problem unless I was to go through and hand sculpt that out. So I wanted to have some mechanisms to help me with this, and Maya gives me that ability. The rigging tools give me an ability. One of the things you can do in spline case is you can actually control the length of the joints. So what I did is I made a little mechanism in here. You can actually see there's keyframes on it right now, but if I go through and use my slider capability here, you can see that I can actually expand those joints out. And what that's doing is causing each one of the little spacers to grow just a little bit larger. Now I put a natural maximum on it because I found that if I got out to like 10, it made it so large that it kind of broke the model. So this is probably an area where if I really needed that pose, then I either need to relax that constraint that I put on, or I need to really consider what it is that I'm doing with this model. You know, I need to make some story and or model that changes. But normally, if I'm not going to be that bent, that little tiny bit of mechanism there, okay, is what allows me to get, you can see how I'm separated right now. The goal was I wanted to get relatively tight to the target, but I knew there was going to become a place where I could be undercompensated so that I am overlapping. Okay. Now, once you go and get something like this kind of set up and staged, then, and you've got all your setups and you've got everything ready to go, then you want to actually export. And we're going to actually see what that process is of exporting. Now, Maya has several really powerful exporters. If you're going to, since we're talking about Formlabs and the Preform software, the two main formats that you're going to want to export to would either be the OBJ format or the STL format. Now, Maya is a powerful tool, but I will say STL has had a little bit of STL's had a little bit of a challenge in Maya because they've gone through about 3 or 4 different exporters, depending on if you count a patch update, an exporter change, Direct Connect, and a few others. And some of those have worked. Famously, a few years ago, you needed to have 2 different patch updates to the Maya software to get it to work. It was a bit frustrating for those of us who are waiting for the STL exporter, something as simple as a file exporter, to get updated. So in Maya 2020, which is the current version of the product, there are two ways to get your model into a format that will go to Preform. STL is working, but they have changed where that plugin is. OBJ is working, it's the same plugin. Now, we're gonna do that right now, but let's say I wanna take a model and I wanna export it, like this piece. I wanna take this piece, doesn't matter which one. If I wanna export it, one of the things that's happening when you do a character rig or a deformation, all these really powerful tools that Maya has, is that technically there are two meshes happening right now. Okay, there is one which is the deformed mesh you're seeing, but there's also going all the way back to when you first made what we call a bind, which is that deformation that connects the skin to the skeleton. It's what's called the skin cluster is the deformer, but there is this thing called a bind pose, and that bind pose contains a record, like a photograph in time of what that model looks like at the non-deformed space. So technically, when I brought this in, it was just a flat model with no deformation. That technically is an image that exists within this program right now. And it's easy to actually show that, because if I take the envelope off the model, it removes the deformation. That is what the model technically looks like according to its transform nodes. No deformation whatsoever. The joints, the deformation, the skin cluster that's doing the smooth bind here is actually performing that deformation to get it up into space. Now, why does that matter? Because sometimes when you export, depending on which exporter you're using, depending on which version of Maya, which exporter, or did you export it out as, let's say, an FBX file and then save it out from a different program to STL? Depending on how you do that, sometimes you may actually export an STL and it's got both of these images in the same file. And there's something really bizarre when you go to look at, let's say, a ring, and you've got the non-annealed, non-deformed ring, and the ring itself kind of overlapped. Okay, it tends to look like an Egyptian Ankh or something like that. It's got two different states currently living within the model. So what you want to do before you export anything that's got a deformation is you want to get rid of that construction history. Now, with most people that have worked within Maya for a while, you're freezing transforms, you're deleting history, these things become kind of, you know, standardized things that you always know to do. But edit, delete by type, history. Now, the thing about deleting history is it's going to kill all that. So once I delete that history, I will not be able to get back to make further deformations to this model. So what you may want to do before you do that is do a file save scene as, and give it a name that's going to be really clear, like pre-export save. Something, save as, and save as often is kind of my mantra within Maya. I do save as before I do elaborate Booleans. I do save as before export. I typically end up having on a production somewhere around 50 or 60 different files by the time I'm done. And it may seem redundant, but file space is cheap. It gets cheaper every year. And your time is not cheap. And if it's 4 in the morning and you've been working on something and you've been forgetting to save, it's at 4 in the morning when Microsoft will launch that update that causes a forced shutdown. And then suddenly you realize, oh my gosh, I didn't save since 11 p.m. I lost 5 hours of my life. And it feels like 5 years. Okay, so what I recommend, save as, delete history, freeze your transforms, then export to STL. So right now, I'm going to do that. I made my little save here. I'm going to do a delete history. I could do delete all by type, but that's going to delete history to the entire scene. Be very careful when you do delete all by type, because you're going to purge everything on every model. And if you need a deformation history for something, you might want to save it. So I'm going to delete all my history just because I can. Notice I don't now. This is what's called a channel box, and there's these translate XYZ, rotate XYZ, scale XYZ. I have no transforms. Now, translate and rotate are the easiest and most forgiving transforms. okay? Scale is incredibly frustrating. Now, scale's powerful, but you normally don't scale objects in the world. Like, you don't take, you know, a wristwatch or a material object and say, I want to make this twice the size, and just scale up your universe, okay? So the problem with scale is if you have lots of hierarchies and you have one object that is a parent of another object, that parent object, if it has any non-111 scale, is actually multiplying the size of the universe for the other object that is its child. That gets to be really, really complicated, and it can make some really bad situations occur. One of which is if they're not one-to-one on the scales, like let's say one of them is scale 10 and another one is scale 1 and another one is scale like 0.1. That means one of those axes is 100 times larger than the other axes because one is 10 and one is 0.1. That means that my space within X or my space within Z might be drastically different. And when you go to export your model, you might notice that it looks like it was flattened by a cement truck and became a pancake. Okay, so you want to make sure that you don't have any non-one scales. You want all of your scales to be 1, 1, 1. That's 100%, 100%, 100%. Okay, now I'm going to do this. I've got nothing, no problems there. So, and all the way, also, whenever you name a file, right now it's called polysurface. That's a terrible name. So let's do Necron tentacle test and just come up with some fun little name here. That name will actually be a part of this object as you save it out. And so if you have multiple shells and multiple meshes, you can actually see those names carried forward. So naming conventions are going to matter. But I'm going to go to do an export. Now, when I go to do an export, I typically, when I'm going to export to STL, I do not do an export all because that is going to take everything. That means joint hierarchies that have nodal attachments. That means all of the other set scenes. Many of these objects right now are too big for the Formlab stage. I'm just going to take this one object, which means I'm going to do export selection, and very quickly I'm going to find that I've got a problem. And I set this up to be a problem because if I go to the different types of files that Maya shows as an export, it has Maya ASCII, which is the Maya file but written out in ASCII character text. It has Maya binary, which is using hexadecimal characters for your numbers. The benefit of ASCII is you can actually hand edit those files if you needed to. Binary, you don't have as much ability to edit, but certain large complex numbers actually get much simpler to reproduce. MEL, which is Maya's embedded language. And then there's other formats that might be here depending on what plugins you have. But notice there is not an OBJ and there's not an STL. So where are you going to find those? Okay, under Windows, under Settings Preferences, there is a plugin manager. There are two main plugins that are going to be really, really important. Now, they ship with Maya, but they're not engaged normally. Now, if you've been using previous versions of Maya, you've gotten used to using the Direct Connect tool set. Going way back in the day to like version 2011, 2012, there was actually a third-party application that we used for STL exporting. But for those of you who might have already started looking down this list, you can see that in here, there is one called OBJ Export. That is the standard OBJ exporter plugin. You can click that, that'll load it. And then if you want it permanently to load, when you load Maya, just hit auto load. And if we scroll down a little farther, you will see one here called STL Translator. This is new for Maya 2020, and it is their new STL export format. So if we hit loaded and auto load. Now when I hit close, and I come back and do the same thing I just did, file, export selection. And when I look down at my drop-down list, you can see that I now have an STL export and I have an OBJ export. Now, we're going to do both. You can actually see I've already got a couple of these tests already in there. So if I do a quick, yes, some of you will know the Spaceballs reference. Test A, that's an XP STL. And if we do export selection again, and we do OBJ, and it's very possible that I did misspell and this is an OBJ. Okay, now, because I deleted the history, because I froze the transforms, everything should be good. There's one other thing that we have to kind of deal with, and it is a bit of an eccentricity with how Maya works. Maya's default system preferences is actually in centimeters, okay? I'm working in millimeters right now, and for those of you, I'll have a link later. Every year at SIGGRAPH, I do a troubleshooting and cleanup techniques for 3D printing class. I am doing one in a few weeks for SIGGRAPH. In that, I have a full set of materials that talks about how to export and how to run size index and make everything you'd need to work with a vendor and deal with this. The reason I'm bringing this up, you can see what millimeters are on this little grid that's sitting right down here, those little check gray scale, and I know it's a little dark. If I hide this a little bit, it's a little easier to see. Okay, well that's roughly 12 millimeters, that's roughly a centimeter, okay? This is roughly about a centimeter to about a centimeter and a half, okay? When I load it into Preform, and by the way, the other reason that sold me on the Formlabs product and why I've become such a fan of their product is because of this program called Preform. Preform is Formlabs staging software for all of their form printers. Okay, Form 1, Form 2, Form 3, Form 3L, even their Fuse, which is their sintering machine. Okay, now you can see a couple of pieces in here. I'll actually be coming back and looking at those pretty quick. But if I want to make a new stage, one of the really powerful things about this program is that you don't have to actually own the 3D print hardware to run a job and to be able to test out what your results are going to be with that hardware. So they didn't make the software, Formlabs didn't make the software hard to get access to. It actually made the material immediately accessible. So right now I'm running with a Form 2 because I have a series of Form 2 printers that I run off of. But let's say I want to run off of one of the new Form 3s or a Form 3L. I can go to the virtual printer because it's not connected to my Ethernet, it's not connected to my USB, it's not connected into my system right now. It knows that it can make virtuals. If I had mine on here, I would get the actual serial name of that printer, like Silly Eel or Electric, Shrimp, or whatever name. They have really fun names. But if I go in here, Form 2, Form 3, Fuse 1, Form 3B, Form 3L, Form Cell. Form Cell is the technology that allows a whole range of their Formlabs printers to work in an automated environment. If you have a printer that you're looking for, you can look for the name of it. You could add it right here. Like if you had it in a specific area for an IP address on your network that was hidden, you could actually by IP add those things in here. It's incredibly powerful because from one computer, wherever that computer is, I can run every 3D printer that I have within my facility. Now, for right now, let's run with the Form 3. Cool, shows me it says it's going to be running it with a virtual printer. If it was connected, I could even update its firmware from here. That's why I say this tool set, even if you don't own a Formlabs printer, even if you're using any 3D program out there, I recommend you guys to download Preform, run Preform. I have my students, even if they're going to Shapeways or another 3D vendor, I still have them run their files into Preform to do their test. If it's valid and can be printed on a Formlabs printer, then I know it's going to work with that 3D vendor. So this becomes a really good proofing tool for them. Now, the other cool thing is I can choose any of the resins. And not just that, here's gray. I could actually choose different versions of the resins. They've gone through 4 different versions of gray. Okay, I still have tanks of some of the old Form gray version 3. In fact, if I really want to get sad, Formlabs Black, I have a version 1 bottle unopened, never used of their original Mark 1 Black. I'll probably never use it, but if I wanted to run a test or see how it was going to work, I could. Okay, so there's my gray. I'm going to run with the standard defaults. I can choose what size I want to run my my slice thickness. Okay, I can hit apply. And this is now my stage. So now we can load something finally in here. Now, if you remember, I had those ludicrous speed tests. I knew that there was going to be a problem, and I ran these ahead of time so we can go them here. The A were the ones I just ran right now. So let's just, it's the same model whether I do OBJ or STL. But notice how small it is. And remember I said there's like a little bit of an issue with I was looking at the measurements and saying millimeters versus centimeters. Here's the problem. STL was written in 1987. That's the year that Predator came out. So the same year that Carl Weathers and Schwarzenegger are like smacking their hands together to show off their biceps is the same year that the STL format was actually written. It was written to support inches. It was written to support millimeters. Well, Maya can support feet, yards, meters, inches, millimeters. It can do almost any size and scale. It's the same size universe. It's just how do they multiply it? Unfortunately, when you're exporting, sometimes because of things that you may have done or going between different programs, and mind you, I went from Maya to my CAD program back into Maya, sometimes it loses sync with what scale is. It's not the end of the world. Scale is actually the easiest thing to fix in 3D printing here. But the interesting thing is, if you look at this, this is a centimeter right here on the Formlab stage. This is far too small to print. This was supposed to be over a centimeter, okay? But because I exported out of Maya, even though it was right size in Maya, the STL exporter, because STL is such an old format, just had a really tough time locking onto it. So what do? Well, it's easy. If you worked in metric and you know your size and shape, you can actually go now take this file and you could just go over to the simplest of tools called scale. I know that this came in 1/10 scale. So I can go and just hit 10, hit enter. Oh, now it's the right size. Now, if I really wanted to test this, notice how it's got an X, a Y, and a Z bounding box, 57.25, 64.48. This is the actual X, Y, and Z bounding box for that 3D object, okay? If I were to come back to Maya, and there we go, check this out. So this was that object, right? When you go into the attribute editor, for any object, Maya is built out of nodes. One of those nodes is called a shape node. And one of the really powerful things about a shape node is that there's a transform node, which is where it exists in the 3D world. And then there's the shape node, which is all of the components that sit inside of it. Well, inside of the shape node data, inside of what we call Maya's attribute editor, I can go under object display. I can go down to the bounding box information and I can look at the exact values. Now, this is X, this is Y, and this is Z, and this is minimum and maximum. So if I take the maximum, subtract the minimum, and I'm not going to load up a calculator for this, but if I was to do that, these numbers, the maximum minus the minimum, and notice how the minimum is negative. When you subtract a negative, you actually add. That means it's crossed over the origin. Okay, so in this case, that is 24 and some change plus 32 and some change. Okay, well, if I go over here and look at that, that's in X. Okay, you could actually see those numbers reflected here. Okay, so in Maya, if you're getting ready to export, this is where I create what we call a part index. And a part index is me going through with every 3D print that I'm going to send to a vendor. And I basically make like a little text file. Sometimes I'll do it in Excel or in another program where I can have it a little more automated. But I will, with every model that I'm going to send to print with a vendor, or even for myself, just so I have a record of it, I create a part index that has the name of the object, the quantity I want to print, if it's got different materials, the material that I want to print from, and then it also has any of the links to the file name, because I might be giving a huge data dump with a whole bunch of different files. And then I will have the X, Y, and Z bounding box size so that that vendor, or my buddy who just happens to be in the other side of the office, can know what size those are and know that I'm giving them the right version, knowing that they're not going to be wasting materials and time printing something not the way I want it to be printed. Okay, so fortunately, if you work in metric, it's usually, if you ever see this type of problem, it's going to be something that is like a factor of 10. It'll either be 10 times too large, or it'll be 1/10 the size, okay? But here's our product. You can see all the different pieces there, the socket, the LED illumination channel, the supports. You can also see some really weird red, whatever the heck those are. Those are what are called unsupported minima. And right now you can see that it's got a little down, thumbs down. This is not printable. Okay. One of the things about Preform software, and again, the support documentation is thorough for this program, but an unsupported minima means that it's not connected to the stage, so it won't print properly. Well, part of the reason for that is I loaded it, but I haven't built any supports for this yet. Now, another thing is when you're doing 3D printing with SLA printing, you want to make sure that you're kind of building like a stalactite. You want it to build off a support because it will actually be anchored to a platform. In fact, this platform is this grid right here, but that will be upside down. Imagine this whole thing dipped upside down and inverted. That will now be hanging, and you'll have an anchorage here, and this will be grown suspended below it. Now, to do a really quick example of what the supports are, I'm just gonna go to this little thing called supports, and I'll just auto-generate some supports. The cool part also, Formlabs has now for 7 or 8 years been releasing new versions of the Preform software to go along with every print resin, to go along with every printer. And the benefit of that is that every version they are getting, using all of that data that they're getting from everyone's contributions, from all of their user group, to customize their algorithms for the different resins, to customize their algorithms for the different print processes, and to tighten up the software. The first versions of Preform was a good program. It used a bunch of out of the, kind of a la carte tools to clean up things, but every version has started to get much more sophisticated. Okay, one of my favorites was a couple years ago, just by updating the firmware on the Form 2, they were able to give like a 30% speed increase to the Formlabs printer just because they were able to update the firmware to change how much elevation the platform translated through in between different slices. So suddenly between like a Tuesday and a Thursday, I had a 30% faster printer just because they've been improving the product. Okay, now you can see the stage has gotten auto-generated. You can see it's got the little words, which are basically the name of my file is auto-generated there. Okay, you can see the actual file name is here. And if I had a STL that had a whole bunch of different pieces here, all those parts would be listed in the model list. You can see that it now prints. Their algorithm was able to auto figure it out. So what's happening here is I can visualize, there's a little slider here. This is the moment that my initial layers, this is what slice 9 looks like. This is what slice 12 looks like. And I can literally watch this. So it's going to build this nice anchorage here to the stage. By the way, remember, this is hanging. So the laser is going to cure that material to that stage. It's then going to start building the automated support features that were calculated during that auto generation. At some point, we're going to see blue, and that's where my model is actually finally being printed. But you can see that it's being built off of those little stalactites, right? And it's going to auto calculate that whole thing. Now, there's different parts, but you'll notice that the software, because of how it went through and did all this slicing operations, which is basically a type of Boolean operation, it was able to predict where everything's going to start to come together. It was able to predict how all this stuff is going to feature out. I can look across the entire spectrum of this thing to make sure that there's no fractures, there's no problems. Okay, it may look like a fracture's right there. That's not a fracture. That's just the bounding box of my object. Okay, and it completes. Now, here's the even better part. They know how long it takes for that resin to cure, the amount of wattage, the amount of laser time a 405 nanometer laser is going to take to cure that material. So based on that material, based on my model, based on the current arrangement, the prediction is that it's going to use 65.02 milliliters. It's going to take 1,002 layer slices, and it's going to take approximately 7 hours and 45 minutes with Formlabs Gray V4. Okay. This is incredible because it's actually incredibly accurate. It gives me an ability to start budgeting not only my time, but also my amount of resin being used. Okay. I can now actually give a prediction to a client when they'd be able to have it. So if it was right now, it's 9:42 on the West Coast, well, I can let them know, oh, you know what, I'm not going to have it until about 7 o'clock, maybe 8 o'clock tonight, so I'll get it to you first thing in the morning. I can predict. Okay. Now, another thing that's really important that I'm going to kind of talk about here is this was with Gray V4. I'm going to, when you saw the initial slide with my name on the little poster there, I have become, at first I was skeptical. I love draft resin. If you've never worked with it, I highly encourage you guys to have a chance to play with this. Normally I like really pristine models, but the reason why I love draft resin is from a client. I need to delete supports for this, but the reason why I love draft resin, okay, draft resin prints with a very, very thick slice. When it's done, it'll look kind of like an FDM filament printer, like a MakerBot, but it's fully dense and it's fast. So remember that other one was about 8 hours, right? I'm gonna hit auto generation real quick, and I promise we'll be getting back into Maya real quick. Because a couple other things I want to show you there. It's going to take me a moment to generate the supports for this, but because I changed the draft resin, the algorithm is changing the support structures to account for that resin. So they're going to be a little thicker. You can see that the interface points are a little more crude. They're not those fine little detail points that they were before, but that means that it's able to leverage that support algorithm to make use of this resin that's incredibly fast. Notice the print time, 2 hours and 15 minutes as opposed to 8 hours, roughly a quarter of the time. So instead of me telling them that I won't be able to get it till tomorrow because it won't be printed until 7 p.m. my time right now, I can have this thing done by noon. That means I can literally get it into their hands probably by like 1 or 2 o'clock. I could start to get them to buy in on something, confirm something, and heck, if they needed changes, I could probably implement those changes, reprint it, and have them a second iteration before the end of business hours today. So rather than having to wait for one bit of feedback tomorrow morning, I could have 2 rounds of prototyping feedback within a short period of time. Okay. There's no minima detected. Minima means that something is not actually attached to the stage, and that means it won't be able to be supported and it won't peel off in between the different slicing layers. Okay, there's a lot of this type of stuff. For that type of stuff, I'd encourage you guys dial into my SIGGRAPH presentation if you're attending SIGGRAPH this year. Reach out to me. I'm always here. We can talk about that stuff as we go. Okay, back into Maya. But like you can see, I'm a fan of the tools. Okay, now, rigging is one of the really big things. Being able to use this tool like a pre-visualization software is really powerful, but there's a couple other really, really powerful things that are in this program that other programs may do, but may not do necessarily well. We're gonna sub this guy out, and that's another thing that's really cool about Maya. If you run Maya on Windows, you can actually run multiple instances of Maya simultaneously. I have 3 different versions running Maya concurrently right now. So there's a couple of different curves here. And I am an advocate, and I use constantly a modeling tool set that a lot of people laugh at and think is dead. It is called NURBS, stands for non-uniform rational B-splines. We're not going to go into an entire lesson on why NURBS is really cool, but let me just use a couple of key points here. One of the reasons why NURBS is powerful is a curve-based modeling tool set, which means anything that you might use from Illustrator or an SVG file, logos, those curves can be brought into Maya as NURBS curves. CAD data, when you take out CAD drawings, that CAD data can be taken out and brought into Maya as curves. Also, if you take out a step file, which is a type of CAD file from a CAD program, when you bring it over into Maya, there is a step file importer, it will bring it over as that BREP file will get brought in as a series of NURBS patches. You might have to do some little maintenance stuff on the back end, but all of that data is directly translatable. Last year at SIGGRAPH at the Formlabs booth, I actually did an example of this, and it's the wings that you could see on the draft resin campaign. I took a model that was from the very first film made at Maya or in Maya at CalArts, which was my graduate thesis film, I brought a file that I had not touched since July of 2000. That means it was a 19 to 20-year-old program. And I was able to bring that NURBS file over and immediately start driving it into CAD within about 5 minutes. So from sitting on an archived data CD to suddenly being able to bring that data back and live and at whatever resolution I needed was really, really powerful. So I've got a couple of layers here just to kind of quickly run through this. So when you take curves, you can do what we call lofts. And by the way, if you're in Fusion 360, Fusion 360 can do all this from the patch tool sets. Now, those lofts look like this, and all that is grab one curve, grab another curve, and in the modeling tool set under surfaces, it's called loft, okay? Now, they look pretty clean. The nice part about anything that is based in a curve-based media, just like CAD, NURBS is only tessellated, turned into triangles, when you render it like we do here on the stage, or when you export it to a polygon or to an STL. Okay. Now, I took those surfaces and I attached them. From those surfaces, I generated 2 additional surfaces, and all I did was I started duplicating them. Okay. The only reason I did this is because I did what's called a rebuild. And on this one, I rebuilt it to 32 spans, and on this one, I rebuilt it to 16 spans. Now, the reason I did that was because I wanted to show you guys one of the things that I tend to use a lot of out of Maya, which is a little bit of scripting. Now, Maya has 2 types of scripting. One is called MEL, it stands for Maya's Embedded Language, and the other one is called Python. Most of you have probably heard of Python. Now, when Python gets executed in Maya, Python has to speak Maya's embedded language. So what we call this bridge between the two is Python leveraging MEL commands is called PyMel, okay? You can use either, okay? By the way, every time you select anything, every time you touch anything, inside of something called the script editor here, oh, let me get my screen to, sorry if there was a shuffle there. I grabbed the wrong icon here. But if you select an object, you'll see that it has different commands. Everything that you do in this program, okay, has an echoed command within this thing called the script editor, okay? Now you can see a couple of my little scripts that I've already kind of got here, okay? Now, I'm not gonna say while loops are truly getting into the deep level of scripting. They are like scripting 101 here. For those of you that are accustomed to doing more elaborate things, and you may have a deep knowledge of how to build full interfaces, user interfaces, build entire programs, fantastic. Maya gives you a platform for being able to do all of that. And if you're very versatile in Python, because you have that full base of a Python programming language that can support MEL, you've got an ability, you can write entire application level quality programs to help you with your tools, okay? But for kind of keeping it simple and helping you to see and visualize a really good example of what you can do here, I created a couple really simple ones, okay? Now, oftentimes we get to things like this, and let's say I wanted to break this up, and let's say at each one of what we call these span lines, now this is U and these are all in V, okay? Each one of these span lines, I might want to run, let's say, a whole bunch of rivets, or let's say I want to cut them up as different panels. But let's say I have 1,000 panels, or I have hundreds, or very specifically, maybe I only want to grab every 3rd one. Well, if I only wanted to grab every 3rd one, I'd have to go through and click, and then shift click, and then shift click, and then notice this is getting monotonous, right? Okay, or how about this? What if I wanted to grab not the solid of the line, but let's say I wanted to grab like a very specific value that's nearby. Well, as I clicked where I just did there with that little yellow dashed line, notice how it says, this is actually an echoed value. That is the V value of 29 point, well, it's almost 10%. It's 10 plus about 324111115, right? It's gonna be very, very difficult for me to go through and you know, grab those specific things. Now, classically, what we could do here is we could do Control-C to copy that little bit of command. I can come down into my mel command down at the bottom in the command line editor. I could type it out, and I could just get rid of all of the little trash numbers I didn't need. And when I hit enter, notice how it shuffles back, but it actually grabbed exactly 29 and 10%. Okay. Now I could go do something like a detachment there to break it up right at that point, or some other operation that's based off of that curve. Okay. But what if I wanted to have the other one that's just a little bit beyond it, that's at that 28.9? Well, now I'd have to go through and I'd have to copy this again, and I'd have to go through and say, okay, now I need to toggle, and I need to make this 28.9. And this becomes, oh look, now I've got two of them selected because I made it as a toggleable as opposed to just what I, select one. Now it's, oh, I can select multiple. But now I have to go do this. Let's say there's 90 of these. I'd have to do this 90 times. Technically 180 times, twice for each span. This is where I might have to end up going through and making up a spreadsheet just so I can automate some of my command writing. And that's laborious, takes a long time. But something as simple as like a while loop can allow me to go through and make an operation that does its job until it satisfies a certain criteria, then it closes out that job. So a couple different ones in here. And I kind of put the comments in here to help you to understand what's going on. Okay, so we're gonna do this one. I don't think I have enough to do the entire 35 here, but let's say I want to create a while loop. Well, what you do is you start off by creating a variable. In this case, I called it test, but $ variable name, okay? And I just set it to 10, which means it's gonna start off being 10 in its value, okay? Now, while, and then inside its parentheses is what is my variable that's being assessed. As long as that value is less than a certain value, in fact, let's make that value 15. Oh, not 155, there we go, okay? While that value is less than 15, which means it'll only ever satisfy as long as test remains below 15, execute this script. Now in this case, the script is pretty easy. Remember we had that thing, and you can see up here, me clicking around in the interface echoed the command, so I can already see what my command is. I don't even have to know all my commands in Maya as long as I can copy paste them. It's kind of like when people first started building websites and they just kind of copied and pasted the parts of the websites they liked, okay? Now, -TGL is for toggleable. That's basically like shift selecting, space, and then whatever the name of the surface is. Now, this surface is not called lofted surface 1, so I may have to change this. If you were really good at programming, you could actually do a command that looked at what you had selected and said, what is the name of the object? Copies that into memory, and then applies that in there, and you could substitute that out with a variable. Okay, but for right now, it's called wing surface, and that was 32 span. Okay, then a dot, the object name dot attribute name, and the attribute is its v value. There's u and v in NURBS, and in this case, what it's going to do is I'm just borrowing that same variable that's being used for the test as my variable name. So when it's 10, this will be 10. When this becomes 11, this will become 11, okay? Then at the very end of that, once it's concluded with that operation, the other thing it's going to do is make sure that it starts adding to that test value. So now that variable test is going to have variable test plus 1 applied to it, so it now goes and increments up to 11. Then it's going to close that all out. Now, this is also a really important thing. If you've run Python scripts, you can cancel a broken script. In Maya, if you make a loop that does not close itself, you will literally create a memory error that you cannot escape out of. When you're writing scripts in Maya, save as often, but definitely before you start engaging a loop, either start the loop knowing that it's good and then only add within that loop very carefully. But if you launch a mel script you can actually create a situation where it does not close itself and complete. Now, I'm just going to hit execute. This is the fun part here, is that you can basically keep all this there. And if you right click on it, you hit execute and it'll go and select. Now it has a whole bunch of them here, so you can see it did some others, but see how these 5 right here are really, really, really bright? That's because those are from this one right here, okay? So what it did is it selected 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it went through and selected, it added 1 each time. So then it grabbed, see how it's the main line, not the ones 10% off. So it grabbed 10, then it incremented up to 11, 12, 13, and 14. It did not do 15 because I didn't do less than or equal, I did less than 15. So basically it concluded with 14 because the moment that it did round 14, jumped up and became 15, it no longer satisfied the criteria, okay? Now, you can see it also grabbed some others, okay? I did one of these for each one of these different criteria. So I did one here that was 32 spans. And if you look here, 32 spans, which is this one right here, same exact variable. The only difference here is notice that I did 2 select commands. I did a select command which was the same as the one we saw up here, but I added 10% and then I added 90%. And I start from 0 and I go up to whatever number. Now in this case on the 32, this is 0 right here. This is 32 right here. So it is going to do everything up to but not reaching 32. So it's never going to do 32 because at 32 it would be 32.1. Well, there is no 32.1 and there is no 32.9. So it basically concludes with 31 and 31 plus 1.1, 31 plus 0.9. So what this does is it allows me to kind of control when it goes, and then because I tailored it in my script to the size and number of spans, I can make this happen really, 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 really simple. Okay, now I'm gonna go through and I'm just gonna echo these out really quickly because I wanna make sure that I execute the scripts. Okay, I'm gonna deselect real quick. Now you don't even have to have the object selected because notice how I named them by name. But if you had done something where it was, you know, echoing back and copying whatever you have selected, you could actually make that command do that. But really quickly, what I'm going to do is I'm going to launch these commands, okay? Okay, so I did it. It launched both of them, right? Notice how what it did. It grabbed this one, even if I didn't have it selected, by plus that number plus 0.1, which is 1/10 of a span, plus 90 per span. So what I basically did is I went around each span plus and minus 10%. Now, why might that be really useful? Well, this is why stuff like this is really useful. Polygons, you can do a lot of different commands, and there's a lot of stuff out there on polygon modeling. NURBS, same way. In NURBS, one of the things you have attachment, detached spans. Most people, when they do a detachment, they get a detach node for every time that they select something and hit detach. So if I had 32 detachments, I would get 32 little output nodes that are each one an individual detachment. Well, here's the fun part. When you have so many things selected and you do a detach, okay, it just makes one detached surface and it gives you every one of those what we call isoparms. Every one of those selected spans has now had its variables included in that single detachment node. Here's the crazy part. Notice all those numbers. They're all like 23.9, 24.1. They're that exact U value or V value plus or minus that percentage. If I wanted to change some aspect here, like let's say I went this and I said, let's make that 23.5. There's it is right there. That's 23.5. It moved over. And if I want to change it back, 23.9, I can change it back. I now have live data. Many who might have worked in Houdini, this is one of those areas that Houdini excels at, okay? Maya is a scripted language and it has tools that are built for this. By the way, every one of these attributes is keyframeable, which is crazy. Okay. Now, the reason I did this, you can see a whole bunch of them right here. I already did them. I'm going to hide them real quick. But I also did this ahead of time so we can kind of see what this does. By doing all those detachments, notice how I can get detachments that even though their shapes are very different, okay, I can automate my selections. So if I wanted to have different operations happen to different ones of these panels, let's say I wanted to take out the negative space here and make them look like they've kind of got some kind of venting, I could do that, okay? There's a lot of different things that we can do within this program to leverage that. But one of the most powerful things Maya brings to the table beyond having a full set of character rigging and technical rigging is a full scripted language. Okay, one last thing, and I know we're getting a little short of time, but one last thing I'd like to also bring to the table here is you have the ability to do certain operations. This is what we call a loft and a revolve. Okay, and I was building this right as we were getting started here, but I may not get it completely over to a polygon, but I'd like to get on the Formlab stage to illustrate. At USC within the School of Art, and then also at Otis within the School of Design, I teach a lot of classes that are on product design and sculpture. And many students might go, well, how do I translate something like this to the equivalent of what I might do in ceramics? Well, they have resins that can literally simulate ceramics. And I see students many times that go through and they make a sculpt, then they go make a silicone mold of that sculpt. And now once it's a silicone mold, you can use whatever castable material you want. They also have castable resins. But in this case, I have part of an object. There's a little bit of a hole at the bottom that I'm going to have to fill in. But let's take a look at what we can kind of do with this, because this will kind of show you one of the other really powerful features that is unique to Maya that a lot of people underestimate. Okay, this feature, and sorry, my screen was a little large. I was using it a little aggressively there. This feature is the ability for you to tessellate to a polygon. And anyone at this point is going, wait, any program tessellates to a polygon, and what you're seeing right now is tessellated to a polygon, so why should I care? Here's why you should care. Almost every 3D program that you have, especially CAD programs, and I love CAD programs, I love Fusion 360, I love AutoCAD, they work really well. Onshape, there's a bunch of really powerful CAD tools out there, but almost every one of those CAD functions, when you export their tessellation engine that goes to STL from your really nice CAD file, is mostly predicated on a concept called chord height ratios, which means they tessellate more where the curves are tighter. They tessellate less where it's less tight. And the problem with that is oftentimes I want to get really nice controlled contours. And when I 3D print, I don't want to see those little slices on my model. I don't want the client to see that it's a 3D model. I want them to see it for the pristine model, similar to what I'm looking at right here. So when we go to modify and we go to convert and we go from NURBS to polygons, because this is a NURBS model, okay? And if you guys have ever gone to Thingiverse or downloaded any model anywhere, and when you've loaded it up and seen that all of the bolt holes or all the screw holes are all hexagons or octagons, congratulations, you have seen the end result of what happens when somebody just uses the defaults. So let me use the defaults really quickly and we'll see what you get. Okay, this is what Maya's defaults are. And notice how we see those little striations there in the 3D. By the way, if you take any polygon and you go to Mesh Display, Harden Edge, I recommend doing this before you ever 3D print a model, because this is what your model will look like when it finally gets into your hand. Every one of those striations is one of the surfaces that you will see on your 3D model. Doesn't matter if it's MakerBot, doesn't matter if it's an SLA printer like a Formlabs printer, okay? That's what you're gonna see, okay? But that's not what I want. I want something that looks clean. It looks clean here, okay? Now I could do this just by changing the tessellation values of my tessellation attribute, probably in about 10 seconds. But the same values we see over there, modify, convert, NURBS to polygons, look at that little options box right there. In Maya, every one of your menus can be pulled off, and every one of your little options has a box. And if you use that box, it gives you every option that goes into that tool. So I say often to my students, use the options box, because every time you don't use the options box somewhere sitting alone in their cubicle, there is a software engineer crying because you didn't use the program they have built for you. Now, triangles are what always get 3D printed, but I tend to like working with what we call quads because I can do further modeling operations in polygons with quads. So I use quads. I also try to avoid the standard fit model because it relies on that chord height ratio math. I use what's called a general fit model. And then there's what we call U and V. V is going to be the vertical because that was the revolve that I did, and the profile was this kind of rounded square shape. So U and V. And then what I do is I change that to per span U, per span V, and then I change it to however many subdivisions I want. By the way, you can change this in the options when you're done. So I'm gonna hit apply or hit tessellate, either way. Boom. That looks a little cleaner. Okay, it still has some faceting, okay? I can still kind of see where those facets are. But check this out. If I go into the NURBS tessellate, which is the node for this, I can change my numbers. If I wanted to export it low res, I can just do 1 and 1, and then it's only one subdivision per span. Or I could do, let's say I want it to be very angled in one direction, but then I want it to be very round in another, okay? In which case I will mesh display, harden edge. See how I might have something where I make it super round in one area, but I like having that little facet as we go up. Or maybe I go the opposite way and I do 10 in this direction, 1 in this direction, okay? Or if I want it absolutely smooth, just 10 in both directions. Now, again, every time I do this, if I go to mesh display harden edge, it forces those normals to become hard. And if I go in close, you can see there's still striations there. Those are striations I will still see on my model, okay? In polygons, in Maya, if you go in and do mesh display harden edge, that will show you the exact tessellation. You will see it, your fingernail will feel it on the model. So if you want more tessellation, dive in and give it to yourself. How many do I need? Now, there is a point where when I do 40 by 40, I am adding 16 times more information here. Now, that's a very, very dense model. But notice when I get close, I'm getting close. I can see some of the striation in there, but barely. My finger, if I run it over it, may feel that tessellation a little bit. Okay. Now, I didn't do one thing that I need to kind of do here real quick, which is I'm going to fill a hole on this, which I should have done a little differently ahead of time, but again, I was under the gun. When I fill the hole on the bottom, it's going to leave a gap that I should have had like a 1 or 2 millimeters of thickness. It's going to take a little time for it. So see how I've got that little artifact right there? Now, it's going to be easy for me to fix because I'm just going to grab this face and pull it down, but it means the bottom of my model has kind of a little bit of an artifact I'm not happy with. But now that I brought that down by a few millimeters, it's got thickness. So it's now actually like a drinking glass, okay? Now, cool. I'm going to export it. Notice it's got construction history. An easy way of deleting construction history, if you just hit Control D, that's your duplicate, and I now have made a copy that has no construction history, but it does have transforms. So what I'm also going to do is do a modify freeze transforms. Now everything's taking forever because everything's got, you know, several 10,000, several 100,000 polygons. Okay, so it's taking me a little bit of time to, it may seem like Maya's crashing, and it's just, I went really aggressive on the numbers. Okay. Once it's done, I can take this over into Preform very quickly, and wow. Well, we hope that Maya comes back from the dead here. I've got 3 versions of Maya running concurrently. That may not be our friend. I'm thinking it's just taking an amount of time to get to the model. But if I were to export it, I could bring it straight over into the program and I wouldn't see those subdivisions. A model, I can actually really quickly just, some of you may have seen it at the Formlabs booth a couple of years ago if you were there, and I know we got to get kind of closed up because I want to give us time for Q&A, but that should work. Okay. Sorry, I'm loading a model into Preform that does a good example of showing you how far down the rabbit hole we can go. Waiting for Preform. So what's happening is a model's downloading off of my Dropbox right now, and then as soon as it's done loading, it'll load into the Preform software. But that model is based on the London Olympics. I made a gold medal with Yoda's face on it for the wearables event we did in Vancouver a few years ago. And that is a model that was somewhere on the order of several hundred megabytes worth of data, a huge triangle count, but it was seamless and it has this big old head of Yoda on it. Just waiting for it to completely download.
Lance, since
yes.
we have just passed the end of the hour, I just want to make sure that we thank the audience for joining in case anybody needs to take off soon. I did have just a couple of questions for you.
Okay.
One that came in from our audience was actually about selecting your mesh for export quality, which I think you actually described in detail.
Okay.
Alrighty. But another question is about kind of materials visualization.
Okay.
So I've personally seen your Necron model in, I think, like clear resin, gray resin, and even our old version of Tough, which is like a translucent.
Yes.
Can you do that visualization in Maya? Like, can you actually view your models in different colors and textures?
Well, the cool part about, yes, you can. Now, we don't, there's not and this might be something that we could work out when we're in Preform. When you're in Preform and you choose a material, that Yoda is here. I just don't know why it's not loading up. But when you load up a model in Preform and you load it on the stage and we make it the right size, the question is, can you visualize what that material is going to look like in Maya? Well, here's an interesting part. In Preform, if I choose like the draft resin, I can see kind of a shaded version of it. If I choose biomedical amber, it's going to show me some kind of looks as equivalent. Now, the reason I say this is something that would have to be kind of worked on, within the Preform software, these are shaders that I assume are a part of the program. They're just hanging out inside the program. Okay, so they give kind of a nice look feel, but they also are what control the staging algorithm. Okay, now this is something that Formlabs would have to determine, but these are shaders. They're just material shaders for the 3D visualization here. But if we knew what those parameters are, there's nothing to say you couldn't actually do that here. In Maya, I kind of used in this picture, I used a kind of a simple shiny, it was meant to look kind of like the blue steel that I was wanting for the finished product, but this is a full rendering engine. Now I'm running the default shaders. There are lots of renderers for this program. Arnold comes as a free installation. There's the standard Maya software. If you happen to have a knowledge of how to use something like Chaos Group's V-Ray. V-Ray's got its own materials. You could go through, and if you're really savvy with using material properties, you could go through and visualize. So if I wanted something that had more of the look feel, I don't know the exact RGB values of the of the castable resin. But if I knew those values, I could go through and match the exact RGB values. And by the way, double click, I can do RGB, HSV, very specific colors and color palettes. If I knew the exact transparency ratio of some of the materials like the tough resin, I could do that too. And then I could have the transparency in here. If material had, by the way, incandescence is a really crazy concept. But if I knew where I was going to have, like with this, when I originally made this, it was painted. It had, after I did it in clear resin, I was able to print it. I did a full a white coat, a black coat that I hand painted that would make everything solid. And so it became like the entire model became a fiber optic that could glow. Okay. I could actually do that and see all that visualization right here. So if they're interested in doing that, it's just a matter of starting to learn how to build up a set of shaders. The other nice thing is Windows, rendering editors, Hypershade. If you're doing a lot of this type of work and you've built your own set of shaders, you could build a library. And once you've got your library of all of your different materials for, let's say this is castable resin, and I could go through and instead of blend, I could say castable resin, come up with a name. That's now the name. File, export selected network. I could take all of my resins, export them as a MEL file that I can keep with me so that now I can hand that to clients. Now that I could take that to all my other projects, I could assign it on to things. So they could see what that material is going to look like for their clients, see what it's going to look like for them straight off the printer. And if they've got a good understanding of how to do, heck, if they had a HDRI light map of their space, they could actually almost pre-visualize what the 3D print would look like by using the actual high dynamic range lighting, just like we'd use in like Iron Man and a visual effects film. So it's very possible. Now, I don't know the exact shading values that they're using within the Preform software, but guaranteed this is like something similar to a Blinn or a Phong. It's not a fully photoreflective, subsurface scattering shader. So if you were just wanting to get that type of shader, I would say approximate it, or even just do a quick RGB sample, which you could do using Photoshop and a screen capture, and then you could start to build these yourself. Be very easy.
Great. Well, thank you. Those are great insights. Before we wrap up, I know you mentioned that you're giving a presentation at SIGGRAPH.
Yes.
I was wondering if you could just share a little bit more information about that.
Yeah.
We can certainly follow up as well over email with some more info about this.
Are you guys seeing my little display here? Is it my, I don't know if the screen sharing is working on this. Are you guys seeing that? Here, how about this? Let's try it this way. Boom, there we go. If anyone's interested, yes, I mentioned SIGGRAPH. Can you guys see that PowerPoint?
I guess, and we actually
okay.
Put it on the screen too.
I made a QR code for it. There's the tiny URL and everything. So if you're interested in this, SIGGRAPH 2020 was going to be in Washington, D.C., but because of COVID, obviously it's canceled. I've given a series of talks on how to do a lot of these really kind of fascinating things in 3D and how to make your products better. Learning really how to dive into what makes a good 3D print. It's about a 90-minute class. The QR link goes to it right there. A lot of what I talked about today gets taken even more elaborate there, and I dive into agnostically how to get the best out of all the programs, really how to get the best in terms of understanding how to stage things within the Preform software. I did not make a link to the Preform software, but I've talked about it quite a bit in this class. I encourage you guys, go to the Formlabs page, download the Preform software. Even if you're just dabbling in the program, or even if you're not using Maya, you're using a different program. If you're interested in learning about 3D printing, Formlabs makes a piece of software for free that supports their print system, but it's incredibly powerful for helping you to understand how to get your model, even if you're going to another vendor like Shapeways. Also, last thing I might say about that, if you're wanting to learn Maya, my suggestion is there is a trial. If you have a .edu email address, it is free for students. You can get a free 1-year license. It's the best. The way I learned it, I had a graduate thesis I had to get done, and I just started dabbling. Most of my students who have gone on to do the kind of the strongest work out of Maya, it's just they dabble. They start making like spacecraft, guns, spaceships, robots, whatever kind of floats their boat. They start diving in, and then they just keep being hungry. Put the carrot in front of yourself and start, making that the thing you do with your evenings. Sure, you can play a video game every once in a while. That's pretty cool. But, rather than just sitting around watching, The Office again, load up Maya while you're loading The Office. Try to make something. The tutorials are out there. The resources are out there. All of the documentation for Maya is there. And there's lots of YouTube videos. And be willing to make a mess. Here's the cool part. You can make a mess. All it is if you don't like it, you hit delete on the file. But make a mess, see what it looks like, load it onto the Preform stage, and see what happens. Most of my students, their very first models that we start working on are Legos, because if you take a calipers, I have several here, but I'm actually using them for my tripod, since I left my tripod in the Midwest. I have multiple calipers, okay? They cost maybe 20 bucks on Amazon. Get a calipers, learn how to use it, get a Lego set, start measuring out Legos, and if you just start measuring and start utilizing your space, you can start modeling, make a Lego. Even if it's a Lego that's identical, like the standard 4x2 block, make one, 3D print it. And the moment that you're able to 3D print it accurately so that it's the right size and it fits with all the other Lego blocks, you've not only learned how to model within the program, you've also now learned how to get that model to a 3D printer. And you've now also gone through the entire process so that now you have taken the real world, mathematically calculated into the computer, and then gone from the computer back to the real world. At that point, change it, stylize it, make it into whatever you want. At that point, you're making your own Legos. And at that point, you are actually a 3D artist making 3D product. It's just a matter then of saying, well, what is it you want to make? Are you just going to copy another person's Lego they've already designed? Or are you going to make a Lego of your own design? But get hungry for making stuff. It's just like how somebody plays a guitar. You don't learn the guitar by buying a guitar and keeping it in the corner. You buy a guitar by getting it and starting to strum it. Even if the chords sound awful, at some point they won't sound awful anymore, and now you're actually an artist using the tool. So have fun, make messes. That's kind of the mantra of all this stuff.
Great. Well, I think that's actually some really wise advice to end on. And Lance, thank you so much again for joining us today. This presentation was just really packed with information about how powerful a tool Maya is for 3D design. So we'll put our heads together to maybe bundle together some more resources for our audience to follow up over email. And thank you to the audience for joining today. We hope that we'll see you at the next session.
Awesome. Thank you guys for attending. Hope you learned a lot. If you ever have fun, reach out to me. If I see you at SIGGRAPH, it's a lot of really fun use, and have fun, make really great models. I'd love to see what you guys make. Stay safe, and yeah, have a great day.